Okay, for our last video in section 3.3, we're going to prove the power rule and change of base formula, and we're going to show you how to use those to do some stuff, good fun stuff. All right, the log power rule proof. Let's look at what the log power rule is. And this says that if we have a power inside the log, so we have a log base b of some a to the x power. This says we can bring that x out front and multiply it by what's inside the log. So, in other words, if we had log base 2 of 7 to the 1,000th power, let's just do 8. It'll be easy to evaluate here. This says that we can bring the 1,000 out front and multiply that times log base 2 of 8, and we get 1,000. Log base 2 of 8 is just 3, so this equals 3,000. But if you were to try to evaluate this in your calculator, it would probably give you an overflow if you tried to type it in like this. So I don't have a new operating system on my computer calculator, but if you try to type this in like you see it there, it would overflow because 8 to 1,000 power, the calculator can't handle that. So let's prove this first. I've already shown you how you can use it. We'll do some more fun stuff with that later on. Okay, so the proof, we are going to let x equal, let's see, I've got an x there. So let's not let it be x. Let's let y equal log base b of m. Well, we can say a since we used an a there. And if I convert that to exponential form, I get b to the y equals a. Now, I can raise both sides of an equation to the same number. If I had 4 equals x, I could say that 4 squared equals x squared, or 4 to the third equals x to the third, or 4 to the negative 1 equals x to the negative 1. I can raise both sides of the same power. So what I'm going to do in this next step of this proof is I'm going to raise both sides to the x power. And that's a valid mathematical operation. This gives me b to the x times y equals a to the x, because we know we have power raised to a power, we multiply powers. Now I have another exponential equation that if I convert to logarithmic form using base b, I have log base b of what's on the other side of the equation, a to the x power equals x times y. And we know when we started this proof, we let y equal log base b of a. And we have proven that log power rule property. So how can we use this? We kind of showed you an example already, but let's say that we had log base 3 of 9 to the 1,000 power. We can't do 9 to the 1,000 power in a calculator, but we can use this to bring the 1,000 outside, times log base 3 of 9. That is going to be 1,000 times 2, or just 2,000. If we were looking at this, we could say, let's say we have log base 4 of x plus 5 to the, let's do 30th power. And that equals let's say 60. Now, you could try to solve this and say 4 to the 60th equals x plus 5 to the 30th, but you can find yourself with a whole lot easier numbers to manage. If you recognize that's a power inside the log, it can come out and multiply, and we get 30 times log base 4 of x plus 5 equals 60. And since I'm multiplying 30 times log base 4 of x plus 5, I can divide both sides by 30 and get log base 4 of x plus 5 equals 2, which is a lot easier equation to convert to exponential form and get 4 squared equals x plus 5. 16 equals x plus 5. And if I subtract 5, I get x equals 11. And it's a whole lot easier to work with the numbers that your calculator can handle. Go 4 to the 60th power, it's a really large number. So that's how we're going to use the log power rule. Not sure why that page is there. That's how we're going to use the log power rule to evaluate logarithms and to solve equations. Hey, let's look at one more thing to prove. This one, we don't use it as much anymore because you have calculators that can do what we used to use this for, but it's a change of base form, and it's something that you might need to come up with and recognize on standardized tests at times or other things. It's also useful for some things in more advanced math, especially when you go to computer programming that have logs with base E or base 10. But they don't necessarily have computer languages that can calculate log base 2 or log base 5 or something like that. Change of base formula says if you have any log with a valid base and a valid number on the inside of the log, that can be converted to any log base C, any valid base C of M over that same log base C of the original base. Now that's kind of crazy. Let's think about what that means for a minute. That means that I can write log base 2 of 5 as log base pi of 5 over log base pi of 2. If you have a calculator with a new operating system, you can type that in and you can validate that. You can put it into some, maybe Wolfram Alpha or something like that. Put those in and see that they're equivalent forms. We would never want to change the base pi, but the two most common bases that there are in computer languages are going to be log base 10 and log base E. And so I very well might want to write a program that has the equation in there that can convert a logarithm like log base 2 of 5 to log base 10 of 5 over log base 2 or base 10 of 2. Or in log base E, it would be ln 5 over ln 2. Those are equivalent expressions. Those are what we want to do to change to bases. I was going to do that on the next page, but I've kind of already showed you. Let's prove this, though. I don't want you to believe me just because I told you. I want to prove it to you. So let's let x equal log base b of m. It's been a while since I've proven this, so we'll see how this goes. If I'm going to, well, let's go ahead and convert this to exponential form like we've been doing. B to the x equals m. And now one of the great things, since we've established this logarithm, we can use the logarithm as an operator. We can perform the logarithm operation on both sides of an equation the same way we can raise both sides to a power, the same way we can multiply both sides by the same number, the same way we can divide both sides by the same number, the same way we can take the square root of both sides, we can apply the logarithm. So what I can do now is I can take the log base c, where c is some valid base, of both sides of this equation. And then I can use that power rule property that we did a minute ago and bring the power on the inside of this log out and get x times log base c of b equals log base c of m. And then, because I just have a multiplication operation here, I can divide both sides by log base c of b. Remember, log base c of b is just a number. It's the power of the base c that gives you what's inside b. And so then I can divide both sides by log base c of b. And get these cancel and give me log base c of m over log base c of b. And that allows me to change those bases into things that are more common. Like I said, some computer languages, some spreadsheet applications, they have bases 10 and bases e stored, but they don't convert automatically to other awkward bases. If we had log base pi of 5, we could say that's the same as ln 5 over ln pi. It's important to understand too, some students will try to cancel those ln's. That's not ln multiplied by 5 or ln multiplied by pi, which is what it would require for you to cancel those. That's just an operator. ln 5 is a number. ln pi is a number. The ln is finding the power of the base e that gives you 5. ln's find the power to base e that gives you pi. So you can't just divide out the ln's. This would also be equal to log 5 over log pi. Or you might even see it show up on a multiple choice test to see if you recognize that that could easily be log base pi of 5. Well, let's see. Could also be log base 7 of 5 over log base 7 of pi. So that you know how this change of base operation works. You can also sometimes, when you're working, you may end up getting an expression that says ln3 over ln2, and you'll need to know that that's the same as log base 2 of 3. So those are things that you can do and you can look for. If you ever had an expression where you had log base 8 over log 2 on a non-calculator part of an exam, and you said, hey, I know that that is log base 2 of 8, well, you recognize that easily. The power of 2 that gives you 8 is 3, so that can be useful to know this property, even if you're not doing computer programming. All right, and that's our part 3 for lesson 3.3.